Hi everyone, so today we're going to be learning about second order differential equations, and these equations are given in this following form. P of x times your second differential, Q of x times your first differential, R of x times your function y is equal to g of x. Now g of x, q of x, r of x and p of x, they're some functions of x, but it also could be just some number, let's say 2. Now today we're going to be focusing on something called homogeneous equations. This basically means that the g of x term is simply 0. And we'd be looking at the left-hand side and solving this. So what are the steps? Well, the first step is to rewrite this equation with this notation. So y prime prime would be associated with your second differential. Y prime would be your first differential. And then y would stay the same. This just makes it easier for the second step, which is calculating the auxiliary equation. So going to the second step, we calculate something called the auxiliary equation. This is given in the form r squared plus r plus some constant. Now, r squared relates to the coefficient of your y prime prime. R is the coefficient of y prime, and then your constant is just the coefficient of your y. It will become a lot clearer once we do an example. And then the last step is to solve this equation and get your two roots. So you have three different cases depending on the roots that you get. If you get two different roots, say root 1 and you get root 2, the two different numbers, say 2 and 3, then your solution will be in this form. But let's say if you get the same two roots, let's say r and r, so both of them, for example, are 2, then you put your solution in this given form here. The last case is when you have complex roots. So this is when you have your imaginary numbers as well. And this is when you have your equation, which is given in this form. So today I'm going to be focusing on case 1, where we have two distinct roots. So today we're going to be solving this following equation. It's given as the second differential plus the first differential, minus 6y is equal to 0. And we're also given something called boundary conditions. Now these boundary conditions are used to solve the constant, which we'll get in our final form, for this case, which is for case 1. So the first step would be to rewrite this in terms of y prime. So d2y by dx squared would be written as y prime prime. Now notice that we have no coefficient here. If we had a coefficient, it would come here as well. In this case, it's simply 1. So we'll get 1 times that. The second bit is to write dy by dx in prime notation, given as that. Lastly, minus 6y stays the same, is equal to 0. And that's first step done. The second step is to create something called the auxiliary equation. Now, this is given in the form of r squared, which relates to y prime prime, plus r, again there's no coefficient, so we don't put anything there, minus 6, there's nothing that we have to put here, is equal to 0. And that's the second step done. The final step is to calculate the roots from this equation. So we can do this by using the quadratic formula, or simply it can be factorized out. And in this case, you're going to have r plus 3 and r minus 2 equals to 0. So from this we can solve and get the two roots. We're going to say root 1 is equal to minus 3 and root 2 is equal to 2. So you set this bracket equal to 0 and you get minus 3. Set this bracket equal to 0, you simply get 2. Now, we've got the two roots. We can put this into our equation, which is given as case 1. Case 1 is written as y equals a e to the r1 root 1x plus b e to the r2x. So in our case, it will be equal to r1 a e to the 3x plus b e to the 2x. Sorry, this should be minus 3. Now notice that these two roots could be written the other way around. So I could have had a e to the 2x plus b e to the minus 3x. It makes no difference to your final answer. So this is the equation, and technically we've solved it. But one thing is, we've been given these boundary conditions, as mentioned before. And to complete this question, we have to find what a and b are. So we have to calculate this value and this value separately. So I'll do that now. First case, we're going to have our first boundary condition given as y x equals to 0 is equal to 1. This is essentially saying that at the point x is equal to 0, y is equal to 1. So we literally substitute these two values into the equation that we just formed. So y is equal to 1 is equal to a e to the minus 3 times 0 plus b e to the 2 times 0. This gives us 1 equals to a. Now anything to the power of 0 is always equal to 1. So this would be a times 1, it's just a, plus, again, times 1, b. And we get this equation out from it. So now we have to use the second boundary condition. Now this involves differentiating what we already had. That's the first step. So differentiating this, we get y prime is equal to minus 3, we bring the power down, a e to the minus 3x, plus, bringing the power down, 2 b e to the 2x. So we've solved this differential. Now we have to put in the values given here. So at x equals to 0, y is equal to 0. So we get 0 is equal to minus 3, a to the power of e times to the power of 0, plus 2b e to the power of 0 is essentially 1. So the equation we get is equal to 0 equals minus 3a plus 2b. And now we have two equations, equation 1 and equation 2. And from these two equations, we solve simultaneously to get a and b. So these are the two equations that we have. Equation 1 given as this, and equation 2 given as this. I'm going to solve this using substitution. So we take equation 1, and I'm going to rearrange to get b, the subject of the formula. So we get b is equal to 1 minus a. And then we take this equation and we put it into equation 2. So wherever you see a b, you put 1 minus a. So we have 0 is equal to minus 3a plus 2, in this case it's 1 minus a. Expanding the brackets, we get minus 3a plus 2 minus 2a, and collecting like terms and rearranging, we will get 5a. We've taken minus 3a minus 2a, taken to the other side, is equal to 2. Finally, a is equal to 2 divided by 5. So now that we know what our a term is, we can essentially put this back into our first equation to get what b is. So we have, from the first equation, we have 1 equals to a plus b is now, is 2 over 5 plus b, and then we rearrange to get b equals 1 minus 2 over 5, and then we say b is equal to 3 over 5. And then our final solution to this would be given as, so our final solution, knowing what a and b are, is 2 over 5 e to the minus 3x plus 3 over 5 e to the power of 2x. And this is the solution to our second order homogeneous differential equation. Thank you for watching.